Hi guys, welcome to Unacademy CET YouTube live session. Myself Sharif. In this particular video, we will discuss the PYQs of KCET and COMEDK on integrals. We are done with indefinite. We'll do definite integrals. That is part 6 of integrals. Alright, before I start guys, please do subscribe and enable the bell icon so that you get the notification of all our classes. Even if you've already subscribed, please do like and share this video. At the end of the session, let us start guys. We'll start with question number 11. Up to 10 I did in the previous sessions. Alright, now before I do this question, I just give an example. Priya, hi Priya. Alright guys, before I start, see, suppose if I have 1 to 0 to 4, and let's say if you have box x dx, just an example. Okay, 0 to 4 box x dx. I'll write all the integral points. That is, this will be 0 to 1. This is 0 to 1, and then you get this as 1 to 2. 0 to 1, 1 to 2. This will be 2 to 3. 2 to 3, and then this is 3 to 4. 3 to 4, and then box x dx. Now this is between 0 and 1, box x will be 0. Between 1 and 2, box x will be 1. Right? Between 2 and 3, box x will be 2. And between 3 and 4, box x will be, between 3 and 4, box x will be equal to 3. Between 3 and 4, box x is equal to 3, and then you integrate. Between the integration of 0 is 0, then you integrate and take the answer. Same logic. Between 0.2 and 3.5, I'll write all the integers. That is, this can be written as 0.2 to 1, and then you get box x dx. Right, plus integration of 1 to 2 box x dx, plus integration of 2 to 3 box x dx, plus integration of 3 to 4 and box x dx. 3 to 3.5, sorry, upper limit is 3.5, so 3 to 3.5, and then this is box x dx. Between 3 and 3.5, and then this is box x dx. So I'll write all the integers. Now between 0 and between 0.2 and 1, box x will be 0. Okay, between 1 and 2, box x will be 1. Between 2 and 3, box x will be equal to 2. Right, and between 3 and 3.5, between 3 and 3.5, box x will be equal to 3 dx. Right, now let us integrate. Integration of 0 will be 0. Integration of dx is x between the limits 1 to 2. Integration of dx is x between the limits 2 to 3. And between integration of dx is x between the limits 3 to 3.5. Between the limits 3 to 3.5. Now if I substitute, this is upper limit minus lower limit, plus 2 into a bracket, upper limit minus lower limit. Okay, plus 3, upper limit is 3.5, minus lower limit is 3. 2 minus 1 is 1, plus 2, plus 3 into 0.5. Okay, so this is 3 plus 3 into 0.5 can be written as 3 by 2, right? 3 into 0.5 is 1.5 only. So this is 3 by 2. Alright, and now this is equal to 9 by 2. Or you directly write 3 plus 0.5 will be 4.5. Okay, answer will be option C. Right, let's move to the next question, guys. This previous KCET question only. Alright, let's move to the next question. Hardly you can apply any shortcut for that. Please do other than integration. I'll do it, Nikhil. If we finish all this integrals, that is definite and differential equations and application, then I'll do vector 3D. Is it okay, Nikhil? One by one only I should do. No, I'm doing all the PYQs. Alright guys, now if I have suppose like this, I gave you this shortcut in my first before this in part 5. I gave you this I gave you this result. Limit should be 0 to pi by 2. Limit should be 0 to pi by 2. This is fx to the power of n. Okay, and then this is fx to the power of n plus f of pi by 2 minus x whole power n dx. Answer is always equal to pi by 4. Alright, now this is limit is 0 to pi by 2, tan x power 7, cot x power 7, tan x power 7. Answer will be equal to pi by 4. I gave you this example in my part 5 as well. Suppose if you have limit 0 to pi by 2, okay, sin x to the power of n with any power, sin x to the power of n upon sin x to the power of n plus cos x to the power of n, and then dx. Answer will be equal to pi by 4. If you have suppose limit 0 to pi by 2, okay, sec x to the power of 5 with any power, sec x power 5, this is sec x to the power of 5 plus cosec x power 5, cosec x power 5. Answer will be equal to pi by 4. Right, answer will be equal to option A. Right, let's move to the next question. Question number 13. This was asked in 2018 paper, minus 2 to plus 2 modulus of x into cos pi x dx. It's a standard NCERT exemplar question, guys. I'll put x into cos pi x is equal to 0. Mod, right? So I need to all find the intervals. If I equate to 0, x is equal to 0 and cos pi x is equal to 0. Cos pi x is equal to 0 means cos pi x is equal to 0 means this will be equal to cos pi by 2. Okay, and then cos 3 pi by 2 and cos 5 pi by 2 and so on. So if I equate this, you will get pi x is equal to pi by 2 and 3 pi by 2. If I divide by pi, x is equal to half, and then this is 3 by 2. Right, x is equal to half, x is equal to 3 by 2. Mod is an even function. If you have suppose minus a to plus a, f of x dx, if it's an even function, then I should write this as 2 times 0 to a, right? 2 times 0 to a f of x dx. If f of minus x, if fx is even, if fx is even, so minus 2 to plus 2, it's an even function. I should write 2 times integration 0 to 2 and then modulus of x into cos pi x dx. Alright, now this can be written as 2 times 0 to 2 can be written as 0 to half modulus of x into cos pi x dx. Okay, and then plus this is integration of half to 3 by 2. Half to 3 by 2 modulus of x into cos pi x dx. And then plus integration of 3 by 2 to 2. 3 by 2 to 2 modulus of x into cos pi x dx. Right, now this is equal to 2 times integration 0 to half. Right, now 0 to half, obviously mod x will be equal to x, that x will be positive. But if I have suppose when x lies between 0 and half, when x lies between 0 and half, pi x lies between 0 and pi by 2. 0 and pi by 2, obviously first quadrant cos is positive, so this fellow will be positive. Again second, x lies between half and 3 by 2. X lies between half and 3 by 2. Pi by 2 is less than pi x less than 3 pi by 2. Alright, between cos is positive in first and fourth, second and third quadrant cos is negative, so this is negative. Next, if x lies between 3 by 2 and x, 3 by 2 and 2, if you multiply by 2, you get 3 pi by 2 is less than x, less than pi x, less than 2 pi. So fourth quadrant cos will be positive, right? So this fellow will be positive. Now I should write this as x mod x will be equal to x into cos pi x dx. Okay, and then mod x will be equal to minus x. This will be equal to minus 1 by 2 to 3 by 2. X into cos pi x dx. Okay, and then plus this is integration of 3 by 2 to 2. 3 by 2 to 2 x into cos pi x dx. Now if you integrate all this, guys, you will get the answer as 8 by pi. Use by parts. Alright, keep patience, don't do silly mistakes. Answer will be 8 by pi. No shortcut can be applied. Alright, this is previous KCET question, I guess 18 or 17 question. No shortcut can be applied. Answer will be 8 by pi. It is NCERT exemplar workload exam, NCERT exemplar question. -2 to +2 mod of x into cos pi x dx. Use by parts, at last you will get 8 by pi. Okay, let's move to the next question. 0 to 1. Okay, 0 to 1 dx divided by e power x plus 1 by e power x. I cross multiply and shift to numerator. This is 0 to 1 e power x dx divided by e power x divided by e power x the whole square plus 1. Okay, I'm going to put e power x is equal to t. Differentiation of e power x is e power x dx is equal to dt. Now even the limits will change. When x is equal to 0, t is equal to e power 0, which is equal to 1. And when x is equal to 1, you get t is equal to e power 1, which is equal to e. Isn't it, guys? So this becomes, when x is 0, t is 1. When x is equal to 1, t equal to e. This is dt divided by t square plus 1. Integration of 1 by 1 plus t square is tan inverse of t. This is tan inverse of t between the limits 1 to e. This is tan inverse of e minus tan inverse of 1. Okay, so this is tan inverse of e. Tan inverse of 1 will be equal to pi by 4. That's answer, guys. Answer is option B. Let's move to the next question. Okay, again this was asked in 18 paper. 0 to half dx divided by 1 plus x square into root of 1 minus x square. Again, you can't apply any shortcut for this. Right? There's no shortcut to this. You have to do the problem in a regular way. See, when you have, suppose like this, integration dx divided by quadratic into root of quadratic. Quadratic into root of quadratic, that is pure quadratic. You should put x is equal to 1 by t. Right? So note the steps now. I'll put x is equal to 1 by t. Dx is equal to minus 1 by t square into dt. Minus 1 by t square into dt. When x is equal to 0, 0 is equal to 1 by t. So this means that t is equal to infinity. Alright, and when x is equal to half, you get half is equal to 1 by t. So t is equal to 2. Right, you get t equal to 2. So this becomes integration of, if x is 0, t is infinity. And when x is half, t is 2. Dx is equal to minus 1 by t square into dt. Alright, and then 1 plus x is equal to 1 by t. So this is 1 by t square. Into root of x is equal to 1 by t. So this will be 1 by t square. This will be equal to integration of infinity to 2. Minus, okay, I will change the limit, make minus as plus. Alright, infinity to 2, I'll write 2 to infinity. That minus will become plus. Sorry, this is infinity, 2 to infinity. This is 1 by t square. Right, now if I cross multiply, you will get t square plus 1 upon t square. This fellow will cancel. If I cross multiply root of t square minus 1, root of t square is under the root. If you take outside the root, it is t. Alright, now this is equal to, this goes to numerator, integration of 2 to infinity. Okay, and this is 2 to infinity. This goes to numerator t into dt divided by t square plus 1 into root of t square plus t square minus 1. Alright, now I'm going to substitute under the root some other variable. I'll put t square minus 1. So let me do it here, guys. So now I actually have integration of 2 to infinity, right? 2 to infinity t into dt divided by t square plus 1 into root of t square minus 1. So this is t square plus 1 into root of t square minus 1. Okay, now I'm going to put t square minus 1 is equal to u square. If I differentiate, you get 2t into dt is equal to 2u into du. This will cancel, that is t into dt I'll get. Now even the limits will change. When t is equal to 2, u square is equal to 2 square minus 1, u square is equal to 3, u is equal to root 3. And when t is equal to infinity, u square is equal to infinity, u is equal to infinity. Now the limit becomes root 3 to infinity. Okay, and then t into dt will be equal to u into du. And from this t square will be equal to u square plus 1. So this is u square plus 1 plus 1. And then this is root of u square. This will cancel. Okay, so you get root 3 to infinity du divided by 2 plus u square, that is root 2 the whole square plus u square. Alright, very challenging question, guys. This is of the form dx divided by a square plus x square. Formula will be equal to 1 by a tan inverse of x by a. Okay, and then plus c. So if I use this formula, you will get this as 1 by root 3. This is equal to 1 by root 2 tan inverse of x by a tan inverse of u by root 2 between the limits root 3 to infinity. This is 1 by root 2. Upper limit will be tan inverse of infinity by root 2 is infinity. Lower limit is tan inverse of root 3 by 2. Root 3 by root 2, sorry. So this is root 3 by root 2. Okay, now this is 1 by root 2. Tan inverse of infinity is pi by 2. Pi by 2 minus tan inverse of whole root of 3 by 2. 90 minus tan inverse is cot inverse, right? So this is cot inverse of whole root of 3 by 2. Okay, I will still not find options here. Okay, 1 by root 2. If I reverse this, cot inverse of x can be written as tan inverse of 1 by x whole root of 2 by root 3 plus c. Okay, that's the first option, guys. 1 by root 2 tan inverse of whole root of 2 by 3. Alright, is this not challenging? Good question, no? So there's no shortcut, guys. You can't apply any shortcut because this is a definite integral question and you can't use options also. You have to do the problem. Alright, it's a previous KCET problem. Alright, let's move to the next question. Okay, and I did one property in my previous video as well. You can use by parts, right? Cot inverse of x is cot inverse of x into 1 and use by parts. That is one way. Second method, if it is neither even nor odd, minus a to plus a f of x dx can be written as 0 to a. This will be equal to f of x plus f of minus x dx. Okay, so this is minus 3 to plus 3. Minus 3 to plus 3 cot inverse of x dx can be written as 0 to 3. 0 to 3, that is fx plus f of minus x. So I'll take f of fx is equal to cot inverse of x. So this is fx is cot inverse of x plus f of minus x is cot inverse of minus x dx. Okay, so this is 0 to 3. 0 to 3, this is cot inverse of x plus cot inverse of minus x will be pi minus cot inverse of x. Okay, and then this is dx, this fellow will cancel. Pi is a constant you take outside, integration of 0 to 3 and then you get this as dx. Okay, now pi times integration of dx is x, this is 0 to 3. This is 0 to 3. Upper limit minus lower limit will be equal to 3 pi. Right, answer will be option C. Let's move to the next question. Right now, if you have suppose 0 to 2 box x square dx, I gave you the example for 0. I gave you this example 0 4 and then you get box x dx. You should write all the integral points. Right, even this was asked in 19 paper, 0 to 2 box x square dx. Even you can't apply any shortcut here. I'm going to put x square is equal to t. Differentiation of x square is 2x dx is equal to dt. And from this dx is equal to dt divided by 2x. So this is dt divided by 2 into x can be written as root t. So dx is equal to 2 into root t. Even the limits will change. When x is equal to 0, t is equal to 0. When x is equal to root 2, when x is equal to 2, when x is equal to 2, t is equal to 2 square, it will be 4. So this becomes integration of when x is 0, t is 0, when x is 2, t is 4. So this is equal to box t. Okay, and dx is equal to dt divided by 2 into root t. Okay, now 0 to 4 can be written as 0 to 1. 0 to 1 box t divided by 2 root t dt. 0 to 1, this is 1 to 2. Box t divided by 2 root t dt. 0 to 1, 1 to 2, and then you get 2 to 3. Box t divided by 2 root t dt. Okay, and then you get 3 to 4. Box t divided by 2 root t dt. Okay, now between 0 and 1, box t is 0. Okay, between 1 and 2, box t is 1. Now between 2 and 3, box t is 2. And between 3 and 4, box t is 3 divided by 2 root t and dt. Okay, now integration of 0 is 0. Integration of 0 is 0. So this is 1 by root 2. 1 by 2. Integration of root x is 2 root x. Between the limits 1 to 2. 2 and 2 cancels. Integration of 1 by root x is 2 root x. Between the limits 2 to 3. Again integration of this is 3 by 2. Integration of 1 by root x is 2 root x. Between the limits 3 to 4. You understand, guys? So this will cancel. This is upper limit minus lower limit. Again this is upper limit minus lower limit. This will cancel. 3 into upper limit is root 4. Lower limit is root 3. So this is root 2 minus 1 plus 2 into this is root 3. If I open the bracket, if I open the bracket, this is root 2 minus 1 plus this is 2 root 3 minus 2 root 2. Root 4 is 2, right? 2 into 3 is 6 plus this is 3 root 3. Okay, so root 2 minus 1 plus okay, I'm going to simplify this final step. This can be written as 6 minus 1 is 5. 2 root 3 minus root 3 is minus root 3. This fellow is minus root 3. Okay, root 2 minus 2 root 2 is minus root 2. Answer is option C. 5 minus root 2 minus root 3. Is it clear, guys? Alright, question number 18. See, this can be written as 0 to 1 whole root of 1 plus x by 1 minus x, right? I'll rationalize the denominator. I'll write into 1 plus x upon 1 plus x dx. This is 0 to 1 whole root of numerator is 1 plus x the whole square a plus b into a minus b is a square minus b square. This is 0 to 1. You get 1 plus x by root of 1 minus x square dx. Right, now if I separate this is 0 to 1, 1 divided by root of 1 minus x square dx, 0 to 1 x divided by root of 1 minus x square dx. Alright, now this is 0 to 1, 1 by root of 1 minus x square dx, right? Alright, this is minus of 0 to 1 minus x divided by root of 1 minus x square dx. I'm just writing that plus is minus of minus. I'll divide by 2 and multiply by 2 here. Integration of 1 by root of 1 minus x square is sine inverse of x. Between the limits 0 to 1, this is minus half. This fellow is of the form f dash of x by root fx. F dash of x by root fx will be equal to 2 root fx. Okay, so this is 2 root of fx, 2 root of 1 minus x square between the limits 0 to 1. This will cancel. So this is sine inverse of x between the limit 0 to 1. Okay, now if I directly substitute upper limit minus lower limit. Upper limit, if I substitute, you get sine inverse of 1. Lower limit is sine inverse of 0. Again, upper limit is root of 1 minus 1. Lower limit is root of 1 minus 0. This fellow will be 0. Sine inverse of 0 is 0. Sine inverse of 1 is pi by 2. And root 1 is 1. So you get pi by 2 minus 1. Answer is option C. Alright, hope this is clear, guys. Let's move to the next question. See, today's class we did minus 3 to plus 3 cot inverse of x. If it is neither even nor odd, then minus a to plus a of x will be equal to 0 to a. This will be equal to f of x plus f of minus x dx. If it is neither even nor odd. Now I take this fx is equal to cos inverse of minus x. Okay, now f of minus x will be equal to cos inverse of minus x. Cos inverse of minus x will be equal to pi minus cos inverse of x. Now if I substitute here, this will be equal to 0 to minus half to plus half can be written as 0 to half. Right, now fx will be equal to cos inverse of x. And f of minus x will be equal to pi minus cos inverse of x. Right, this will cancel. This I'm going to cancel. You will get pi integration of dx is x. This is 0 to half. So this is pi by 2. Right, answer is option D. Okay, let's do one more question, guys. Question number 20. See, again, I'll use the same property. Minus a to plus a. Minus a to plus a fx dx. All these are KCET, previous KCET questions only. Minus a to plus a will be equal to 0 to a. This will be equal to f of x plus f of minus x dx. Okay, now this is minus pi by 2 to plus pi by 2. Okay, and then you get cos x divided by 1 plus e power x dx. Okay, now this is equal to 0 to half. F of x will be equal to cos x divided by 1 plus e power x. And f of minus x will be equal to cos of minus x divided by 1 plus e power minus x dx. So this is 0 to half. 0 to half you get cos x divided by 1 plus e power x. And cos of minus x is plus cos x only by 1 plus 1 by e power x dx. Is that okay? I'm going to take cos x outside. If I take suppose cos common, this is 0 to half. Take cos x common, you will get 1 by 1 plus e power x. And this fellow goes to numerator. Cross multiply and shift to numerator. you will get e power x divided by e power x plus 1 dx. Okay, now this becomes this becomes 0 to half, 0 to pi by 2. Okay, cos x out, you will get 1 plus e power x by 1 plus e power x. This fellow will cancel. Integration of cos x is sin x between the limits 0 to pi by 2. Upper limit is sin pi by 2 and lower limit is sin 0. Sin 0, 0, sin 91, right? Answer will be equal to option A. Right? So I'll stop here, guys. I'll continue with this in my next session. If you haven't subscribed the channel, please enable the bell icon so that you get the notification for all classes. Please do subscribe the channel, and if you've already subscribed, please do watch and share this video, guys. Please like and share the video. Thank you, guys. Thanks for watching. Plus root fx and so on up to infinity, then dy by dx is always equal to f dash of x upon 2y minus 1. Alright, now I just give an example. If you have suppose y is equal to root of sin x plus this is root of sin x plus root of sin x, okay, and so on up to infinity, dy by dx is equal to difference divided by 2y minus 1 will be there. Differentiation of sin x will be equal to cos x. That's it, guys. That's it, guys. Within 10 seconds you get the answer. Same logic. This answer will be equal to 2y minus 1 and differentiation of x will be equal to 1. So answer is 1 upon 2y minus 1. Answer is option D. Thank you, guys. Please do follow us in the YouTube. Please subscribe the channel so that you get more updates. Thank you, guys. Thanks for joining. Today we will discuss a wonderful shortcut on wonderful. Hi guys, myself Sharif. Welcome to our channel. Today we will discuss a wonderful shortcut in differentiation. Let's say you have a question y equal to root x plus root x plus root x and so on up to infinity. That is infinite series differentiation. It's a previous KCET problem only. If I have suppose y is equal to root fx plus root fx plus root fx and so on up to infinity. Let's say you get a question like this, then dy by dx is always equal to differentiation of f is f dash upon 2y minus 1. I just give an example. Let's say if you have y is equal to root sin x, okay, plus root sin x plus root of sin x and so on up to infinity, then dy by dx is always equal to differentiation of sin x is cos x. You get cos x upon 2y minus 1. That's it, guys. If I differentiate this, denominator 2y minus 1 will be there. Differentiation of x will be equal to 1. Answer will be option C. Alright, please do follow us for the more updates, guys. Thank you. Thanks for joining. Problem using the shortcut method. Suppose if you have like this can be written as x to the power of half y to the power of 1 by 3 is equal to x plus y whole to the power of 5 by 6. I can write this as x to the power of half y to the power of 1 by 3 is equal to x plus y whole to the power of 1 by 2 plus 1 upon 3. Alright, now this is of the form x to the power of m y to the power of n is equal to x plus y whole power m plus n. Dy by dx is always equal to y by x. That's a standard NCERT exemplar result. This m and n are constants. It can be anything. Even if I have suppose x power alpha y to the power of beta is equal to x plus y whole to the power of alpha plus beta, then dy by dx should be equal to y by x. So answer for this will be equal to y by x. Thank you, guys. Thanks for joining. Please do follow us for the